Example 3 for writing rational expressions in lowest terms. All right, so same thing like we did like in example number 2, we want to go ahead and factor the numerator, factor the denominator, and then any common factors we can go ahead and simplify and then have our simplified rational expression. Okay, so this right here, by face value, it looks kind of tempting to be like, oh, a minus 10 and 10 minus 9, they're about the same. And unfortunately, that can't be the case. There has to be, if there's an a minus 10, there has to be an a minus 10 on the bottom. Or if there's a 10 minus a, there must be a 10 minus a on top. Okay, so really, all that we really need to do here is we just got to do one simple thing. And it doesn't matter if you do it to the top or bottom, but we want to factor out a negative 1. And let's just do that to the top here. If I factored out a negative 1, okay, so negative 1 times what is a? Well, that would be negative a. And then a negative 1 times what is negative 10? What's a positive 10? Okay, and so then on the bottom, we have 10 minus a. Okay, so by looking at this right here, is negative a plus 10 the same as 10 minus a? That's actually true, because negative a, 10, 10. Right? Multiple or addition is commutative, meaning like you can do any, it doesn't matter, 4 minus 5 or negative 5 plus 4, they mean the exact same thing. You're going to get the same thing right there. So this is exactly the same thing, right? And if it makes you feel better, you can go ahead and just switch these two, right? Like you can say, oh, okay, negative 1, and now I'm going to switch it. So this is 10 minus a on top, and then on the bottom is 10 minus a. So now, I mean, it looks exactly the same. Cross those out, and all we have is negative 1. And that would be it for that one right there. So that one, right, just, I guess a general rule is if you see the exact same thing except they're reversed, it's always going to be negative 1. But just to show that, you want to go and factor out a negative 1, okay? For this guy right here, if you want to factor the numerator, you want to recognize that that is a difference of squares, meaning a squared minus b squared. That is always going to be a minus b times a plus b. And so notice that our first term is 81, which is 9 squared, and y squared is our second term. So it fits this criteria where 81 is our a and y is our b. So if we do that, then now so it would be 9 minus y, 9 minus y, and then again 9 plus y. Okay, so I'm just, the way that you just got to be able to recognize what form that this is in. This is in the difference, the minus sign, difference of squares form, okay? And then right here in the denominator, we have y minus 9. Okay, so again, very similarly, y minus 9, and oh, so actually those are the same. So that should be good right there. Oh, you know what? Actually, they're almost the same, right? This is y minus 9 and this is 9 minus y. So we have this same thing right here where it's almost the exact same thing. So really, we learned from last example that this right here is just negative 1, right? If you want to, you can factor out a negative 1 in the numerator or in the denominator, but basically what's going to happen is that these are going to cancel out, leaving us with negative 1. So it's negative 1 times 9 plus y. See this right here? Or if you want, you can multiply it through and do negative 9 minus y, or you can just switch them around and do negative y minus 9. But yep, so we just use what we learned from here, applied that guy, and just distribute that negative 1 through.